Welcome to Six Sigma Online Certifications. We are on the topic Analyze Phase, Data Analysis, Distributions, Part 1. The basic distributions which we are going to study are normal distribution and binomial distribution. In this video, we will discuss about normal distribution along with central limit theorem. A distribution is a mathematical function based on histogram shape of data. Histogram is a graph of frequency versus measurement, which we studied in detail in our video 6 Sigma Fundamentals Quality Tools Part 7. We will discuss about normal distribution. Normal distribution is basically a bell-shaped curve, and therefore it is also popularly known as bell curve. It is symmetrical. That means if you divide the distribution right from the center, it will be divided from the mean, and it will have 50% data on one side and 50% data on other side, making a mirror image, and which makes mean equal to median, because 50% of data is less than it, 50% is more than it. Also in mean we can see the frequency peaks and is the highest frequency value, and therefore is also equal to mode. So a normal distribution, the necessary condition is that mean is equal to median is equal to mode. The third condition is inflection point. The inflection point is the point where the curve changes its slope in the other direction. So we see the curve inflection point in normal distribution is exactly one standard deviation away from the mean. So the two parameters which define normal distribution curve are mean and standard deviation. We'll discuss about central limit theorem and why it is important. So whatever be the original distribution of the population, the distribution of the means of the samples taken from the population will tend to follow normal distribution. Principally it means that whatever be the distribution, we can make it normal by just plotting its average values. The mean of the distribution, as we know, the normal distribution is defined by two parameters, mean and standard deviation. So mean of this distribution of sample means will be equal to population mean, and its variance will be 1 by n times of that of population. That means standard deviation is sigma by root n. So this theorem gives us inkling that why normal distribution is so important, because even if it is not normal, we can plot its averages and do a lot of studies based on normal distribution understanding. So we'll now understand normal distribution calculations. For mathematically oriented people, they can see the function which normal distribution follows is 1 by sigma 2 pi multiplied by e raised to minus x minus mu whole square divided by 2 sigma square. So only two variables are sigma and mu, and x are the different values which it takes. For understanding better normal distribution curve, we will understand what is z-score. Z-score is a value which is given by x minus mu divided by sigma. X is any value for which we are calculating z-score, and mean and sigma is for mean and standard deviation are taken from the population. So if we take a representative sample which has mean of 30 and standard deviation of 5, we need to know what is the z-score for 20 and 35. So how we are going to calculate? For 20, x is 20, mean is 30, divided by standard deviation of 5, we get minus 2, which indicates z-score of negative indicates the value is below mean. If we see 35, which is more than 30, it will have a positive z value. So 35 minus 30 divided by 5 gives me plus 1 z value. Now we will understand normal distribution calculations. If the average of the sample is 30, representative sample is 30, its standard deviation is 5, we want to calculate what is the percentage of pieces that will lie in the range of 25 to 35 mm. So we know Z20 is minus 2, Z35 is 1. Now we'll try to calculate percentage pieces between 20 to 35. We'll first calculate area to the left of 1, because 1 is higher value. then we'll subtract the area of left of -2, and then we'll get area between 35 and 20 and 35. So if we see, this is area for Z35, which is equal to 1. So area left of 1 is 84.13. If we subtract area of -2, which is indicative of Z20, the resultant we get 8413 minus 2228, we get 8185, which is 81.85% of the pieces will be between -2 and 1, and will be all between 20 and 35 millimeter. This is how we calculate. If you want to do the calculation using the standard charts, what we can do, we can take a standard chart, look for where is Z is equal to 1, and for that Z is equal to 1, we have 8.8413 in our Z table. We search for -2, we calculated for 20 minus 2, we got 0.228, which we put it here, and we can calculate from the tables. Also, this can be easily done in Excel. You have to use function normDist, which is NORM, which indicates normal distribution. DIST is distance. So if you write 20, it is calculating Z value for 20 for a population which representative sample is mean 30, standard deviation 5, and just write true to get the left side area. So we got this area of -2 is 0.228, and then same way we calculated for 35, 8413. So this can be done in Excel as well as using standard tables. This can also be done very fast using Minitab. Minitab does not require calculation of Z, it can directly calculate these values. So if we have average of 30, standard deviation of 5, we want to calculate the pieces between 20 and 35, we go to Minitab, we go to graph, we go to probability distribution plot, we go to probability, we click OK. Our mean was 30, our standard deviation was 5. We want the percentage values between 20 and 35. So we have to just write it and click OK, and we get the area between 20 to 35 is 81.868%, and which is what is we calculated otherwise. Graph probability distribution plot, view probability. In distribution, just put mean as 30, standard deviation as 5, shaded area, put middle, take x1 as 20, x2 as 35, and we get the answer. So Minitab is much quicker. So we understood how to do normal probability calculations. Thank you very much for testing your knowledge on this video, or for Six Sigma certifications, visit leandigit.com. For more knowledge on the topic, please subscribe our channel.